Hey, what's up guys? Yankee here, and in this video we will be talking about how we can generate artifacts from the code generated by large language models. So we all know large language models are really good at generating code, but that's about it. You have to copy the code, you have to paste it on your code editor, and you have to run that code to actually see the result of what that code is all about. What if you could generate the code from the large language model and run it instantly? That's what we are going to do today. So let's look at some of the examples. So if you have been using the Canvas feature of ChatGPT, it's kind of similar. It generates the code, and if you click on preview, it will render your code and you can immediately run that application. The term artifact generation was actually coined by Claude, and as you can see, I can toggle between the code that the Claude generated versus the preview of the code that is being run. So similar to this, I always wondered how you can build this on your own. So in this video, we are going to learn how to build this of our own. So if I come to this, as you can see, we have this interface where the code is generated and you can preview the application. So similar to what we could do with ChatGPT and Claude, now you can do it on your local machine with your own code. So without any further ado, let's get building. First of all, let's start by creating our project directory. For this, I'm going to call it LLM with artifact generation. I'm going to go inside of this directory. I'm going to create a virtual environment and then I'm going to activate it. And for this project, I'll be needing Streamlit, OpenAI, and Docker. Make sure you have Docker desktop running on your machine or Docker CLI. Once we have listed this dependencies, install them. All of my dependencies are installed, and now I'm going to create a file called app.py, and I'm going to open this directory on VS Code. And on the app.py, I'm going to add all of my imports. We will be using the rest of the imports later on, but here we have the entry point to our application where we are setting the page title. We are creating two different columns, and on the second column, we are adding two different tabs. So first column is for all the chat interaction and all the buttons we want to put for user interaction. And tab 1 and tab 2 is for generating the code and showing the preview of the code. So if you have watched my previous video on how to create a chat application using a large language model, 20 or 30% of this video is primarily going to be just that. So to go into the detail about how I build the chat application, you have to watch my previous video because I'm going to speed run that section just to save some time. Having said that, let's come down to the bottom, and on the first tab, we are going to create a container which will contain all the messages that we pass to the large language model, and we can show the chat history. So we are going to set all the messages on our Streamlit session, and we are going to use Streamlit chat message to pass different roles and message to the UI. Since we have not defined any session for the messages, we are going to create a function which is going to be called init session. Just so that Streamlit does not throw us any error, we are going to check if there is messages on the Streamlit session. If there is no messages, then we are going to pass a empty array. And once we have the init session, we need to initialize the session immediately when we start the application. Now let's create the section where user will be interacting with our application. So we put the header of our application as artifact generator. Then we create a select box where the user will be able to create different types of artifact. So in this demonstration, we will be showing how we can generate artifacts that's relate to Streamlit, Vue application, and static application. That's your basic HTML and CSS. And we also have this session state, which will make sure that we cannot select different types of artifact while we have one type of artifact selected and we are building artifact during that session. And below we have the chat input where we ask the input from the user, and on submit we have disable selector. We don't have this function yet, but we will be adding that next. We will also have a toggle if you want to use a remote model or if you want to use a local model. For local model, I will be using Olama. So if you don't have Olama installed on your machine, please install it now. For that, you can go to olama.com and then download the model depending on your platform. And on the bottom, I just have a separator. You can ignore this if you want, or you can delete this. I have a reset button where I want to reset the whole application, and then I have download files button. We will be generating artifacts, we will be generating code, and once we are happy with the code that is generated, we want to download it and maybe we want to work on them further. So this is for that purpose. Now coming up, we don't have the disable selector. Let's create that. So disable selector is going to be a callback function, which is just going to set the disabled state as so that the text form will be disabled during the time when we are generating the code and showing the artifact. And since select box disabled is part of the Streamlit session, we need to initialize it in our init function as well. So if we do not have select box disabled in session state, so we are just going to put select box disabled as false. So disabled false means we will be able to type on the form field. True means we will not be able to type on it. We can see that later on. Now our UI is ready for the most part, so we can run the Streamlit server and see how our application looks like. So I can go to localhost 8501, and as you can see, we can choose between different type of artifacts. So why do we have different types of artifact? Because based on the artifact type, we will have different type of system prompts to instruct the large language model what kind of application we would want. So Streamlit would have its own system prompt, Vue would have its own system prompt, and so on. We will see that later on, and this is the prompt field where you can add your prompt. If you want to use local models, then we can like toggle between these. If you want to reset the application, we have the button, and to download the files that the large language model generated, we have this button. And this is the column 1, and this is going to be our column 2, where we have tab 1 where we will be displaying the code, and this is the tab 2 where we will be displaying the preview of the code that the large language model generated. Now let's go back to the code. Since we have our UI ready, now I'm going to add a function that would be able to make a call to the large language model. So the call LLM will take a system prompt and a prompt from the user. If you are using local mode, then we are connecting directly to the Ollama server. We are using OpenAI SDK because we can just change the base URL and we can point to any OpenAI compatible servers, and we don't have to dabble around with different SDKs. So this makes working with large language models really easy, and we are going to use Llama 3.2 3 billion parametered model as our model of choice for generating codes locally. If we do not have the local mode on, then we are going to be using the Google's Gemini API. Why? Because it's free and it's really good for the purpose. And for this one, I'm using Gemini 2.0 Flash. You can like change it to Gemini 2.5, whatever, but I'm happy with Gemini 2.0 Flash. And for this, you would need an API key. So to get an API key, you have to go to aistudio.google.com, go to get API key, and from here you can click on create API key, select your Google Cloud project and get the API key. Once you get the API key, you have to come to your terminal and you have to do export open AI API key equals to whatever key you copied, so your API key here. And once you do this, when you run this Streamlit application again, it will be taking your API key and passing it to the OpenAI SDK. And here we are just maintaining the chat history. And here we are making an inference request to the large language model. Since we have stream equals to true, we are getting chunks of data from the large language model. So we are going to iterate through each of those chunks and return the result. So for our use case, large language model will be creating code in code blocks, kind of like if it's generating Python code for Streamlit, it will have Python followed by all the Python code inside. So Python code here, which will be like import Streamlit as st and something like this. So to capture this code group, we need to create a function which will look at all the output generated by the large language model and only grab the code output. For that, we are going to create a function called getCodeGroup, and depending on the code block that we pass, it's going to return us that code group. Now we have a function to call the large language model, and we have a function to grab the code generated by large language model. We should actually be calling the large language model. So if the user has entered the prompt, we are going to call the large language model. We are going to store the user sent message on our chat history. Then we are going to call the large language model. Once we get the response, we are going to write the prompt returned by the user, and then we are going to stream the message coming from the large language model, and then we are going to be updating our chat history. This is very important to have a linear chat history, so every time a user sends a message and then the AI replies to it. And a matter of fact, our application is kind of ready. If you want to just query the large language model, you can do so and get the result on the UI. So our server is running. I'll go to the browser and I'll refresh the page. Currently I have selected Streamlit, but it does not matter what you select because we do not have this functionality yet. I already have Ollama running on the background, so I'm going to use a local model. So I'm just going to say, hey, how are you? And then it's going to get a response from the large language model. As you can see, nice to meet you. As you can see, we have a nice linear chat history because of all the session state that we are maintaining on our application here for the user and here for the message sent by the application. or the LLM. So this is all fine and good. Now, as you can see, if I selected Streamlit, it's going to assume that I will be selected on Streamlit throughout the session until I refresh the app. That's where select box disabled comes into the picture. If I refresh this page, I'm again going to have this option. Let me get back to my code. I'll stop the server for now. I'll create a file called models.py where we will be adding not the AI models, but the data models for the application. So let me go to models.py and I will have all of these data structure. We'll come back to prompt later on. So I have this pydantic model where I'm defining the name of the artifact, which in this case will be, let's say, Streamlit, the prompt, which is going to be the system prompt, code block type, which is going to be like Python, HTML and Vue, the file name to be generated, and the image name. Since we will be running the generated code on a secure environment, secure sandbox environment, and that is going to be Docker containers. So we are going to build Docker image for each of the artifact type we have mentioned. Once we have the Docker image built, we are going to mount the code inside of the Docker image, and we are going to open a host port, mapping it to the container port so that we have access to the application. And then we have the container command if you want to run any commands inside of the container while it's running, or to run the container. And we have the file path, which we will come back to later. And based on these metadata, we are going to fill the details for all of the different types of artifact we want to generate. So for now, I have Streamlit, static, and Vue. If you want to add other artifacts in the future, you just have to fill in the details here. So first of all, I have Streamlit and the name is going to be Streamlit. I will have a Streamlit prompt soon. The code block type will be Python. So this is basically Python, and our code goes here. This is what we are trying to capture with this metadata. Container port, our application will be running on port 8500, and we will be opening a port 8500 on our local machine as well. Ron.py is going to be the file that is going to be mounted inside of the Docker container. So this is going to be a static file based on the different type of artifact, and the image name is going to be Streamlit image artifact latest. So whenever we want to run any kind of Streamlit artifact, our application will look for this image. It will run the container. The generated code would be put inside of run.py file. It will be volume mounted inside of the running container, and we will open up the ports so that we can access it on our local machine. Don't get overwhelmed with all the verbal instruction. We will be seeing this in practice soon enough. And here we have the container command. So to run the Streamlit application, we are running Streamlit run.py, and the server port is going to be 8500. And for the server address, we have the whole network address. Same for the static, we'll have a different prompt. Port is going to be different, and we are going to mount index.html inside of the image. And for Vue application, we are just going to be mounting app.vue application inside of the artifact image. And as you might have noticed, I have managed different ports for different type of artifacts so that we do not have conflict of ports. So once we have this, we need to have prompts for our application. So I'm going to create prompts.py file. I will head to prompts, and then I'm going to paste in all of my prompts. So all the reference for the code that I'm showing right now would be linked in the description on my GitHub page. So if you like this repository, give it a star. So we have a default prompt, which we are not going to go into, but here we have Streamlit prompt, where we are saying like you have to create a Streamlit application, and we are also giving it a list of libraries that it can use inside of the application. This will be all the packages that we will be installing inside of the Docker container. And this is just the generic system prompt which instructs the application how it should build the application, how it should structure the application. And the important bits are the code should be inside of the Python tag, and also the logic should be contained in a single file. Why? Because all the code that is generated by the large language model, we are going to save it on a local file, and then we are going to mount it inside of the Docker container. So this is where the file name comes into the picture. If you read all of the system prompts carefully, we have the same pattern repeated for all of them. So for static, we have the HTML block for all of our code contents. We have to have a single index.html file. Same with the Vue application as well. And we are instructing how to style the application, what CSS frameworks to use, and so on. And for Vue application, we'll have the Vue block. And if I go here, you can see the Vue block mentioned here as well. So once we have the system prompt, we can go back to our application app.py. And then we can start importing artifact selector, so let me come down, and on our column 1 here we have the artifact type selector, and we have Streamlit, Vue, and static. So based on whatever the user chooses, we need to get the appropriate artifact metadata so that we can use it on the application runtime. So for that, I'll come down here. I will paste in these two variables. So artifact metadata is going to be artifact selector, and we are going to access the artifact type selector. So that is going to be either Streamlit, Vue, or static. And the container name, we have the image name, right? But when we are running the image as a container, it needs to have a container name. So normalize the name. I'm going to write LLM Artifact to indicate that it is part of our application. And then the artifact metadata's name. So it's going to be LLM Artifact minus Streamlit minus static minus Vue, depending on what type of artifact we are generating. And if we come to the response type, when we are calling the large language model, right now our system prompt is you are an intelligent AI, you are an intelligence AI. Okay, that's a typo. But we can now remove this altogether and then pass system prompt as part of our artifact metadata. So if the user has selected Streamlit, we will be grabbing the system prompt that is part of the Streamlit application. So we have the artifact metadata, which is going to be this for the Streamlit, and it's going to access the prompt, which is going to be this prompt. So we will be passing that to our large language model. And now that we have the LLM response, we also need to grab the code generated by the large language model. So we have this generated code section where we will pass the LLM response, and we will get the code block type based on the artifact we have selected. So for Streamlit, we will be selecting Python like this. Now, once we have the prompt and the generated code, we are going to grab that code. So if we have the generated code, and if there is a file name in artifact metadata, this is necessary because we are create a temporary directory, and in that temporary directory we are going to create a file name that we define in our artifact metadata. So for Streamlit, that is going to be run.py. So inside of this directory, we are going to create a file called run.py, and then we are going to open that file, and then we are going to write to that file whatever code was generated from it. So we are just going to grab the code group, and we are going to add it to our file and save it. And then we are going to put artifact metadata file path, which you do not have to fill in the beginning, as the temporary directory file path. Why do we need this? This is going to be the mount point of the file from our local machine inside of the Docker container. So having said that, let's create a function that is going to be creating Docker containers for us. So that is going to be execute Docker function. This is going to take the host path, which is going to be the artifact metadata.file path, and the artifact metadata. So whatever artifact metadata was selected for this session, so can be any one of these, and the container path, which is basically where do we want to mount this host path inside of the container. So by default, it's going to be home, runner, and application. Why we have this static value, we are going to see that a bit later on. We are going to define our Docker client from the environment. So if you have Docker running on your machine, and if you have Docker host environment variable set on your machine, it is going to get the Docker client based on that. So if I do env grep docker, as you can see, my Docker host is running on this Unix socket. So you need to have this on your machine for this to work. And then I'm creating a volume mount where the target is going to be the container path and source is going to be the host path. And the type is going to be bind, and read only is going to be false. And then we create a container. So all we have to do is client.containers.run, and to get the name of the image, we are going to do artifact metadata.image name. And then for the volume mount, we are going to pass the mount as a array. And then ports, again, we are going to use the artifact metadata. We have the container port and the host port, and we are going to pass it as a dictionary, and detach equals to true. We want to run the container in the background. So this is equivalent to passing -d on your docker run command. So if you do docker run -d, it's basically equivalent to that. And then we have the name of the artifact, which is going to be LLM artifact metadata.name. Started, we will get a container ID, and we are putting that container ID into the Streamlit session. And basically we are just returning the container ID. If we have any errors, We are going to show the error, and then we are going to show the X icon. We are going to print the error on the console as well, and we are going to stop this Streamlit application. So execute Docker is kind of like start Docker. And now once we have started the container, we need some mechanism to stop the container, obviously. So for that, we have the stop container function, which will just get the container name. This will again get the Docker client from the environment, and it will get the container. So with the container name, and then it will just call container stop, and it will remove the container. And we are just going to return a string which will say the container has been stopped and removed successfully. If the container is not found, there's an error. If we cannot capture the specific error, the generic error is like we failed to stop the container for some reason, which will be on this text. So at this point, we have pretty much most of the code that we require to be running our application. So next is to create the images where our application code will be running. And for the first example, I will be building an image for a static artifact type because it's the easiest to create. For that, I'm going to create a directory called Sandbox, and inside of this directory, I'm going to create another directory called static, and followed by creation of Docker file inside of that directory. So if I hit enter, and if I look at my file explorer, I have Sandbox, and inside of static, I have a Docker file, and inside the Docker file, this is my Docker file definition. I'm using Node 20 Alpine because I want to keep my image lightweight, and then I'm going to install a npm package called serve, which is going to serve static files. I'm going to create my work directory as home, runner, and application. You might have seen this earlier as well. So if you go into execute Docker, so our container path is home, runner, and app. So every time we are running our container, we will be running from this location, and we will be exposing the port 8080. This is just for metadata. This line does not do anything except provide the metadata. And here is the command. We are going to serve, and we are going to serve in the current working directories. So it will serve any HTML files it will find in the current working directory, which is going to be this, and it's going to open the port 8080. And that's kind of it. This is our Docker file. Once we have this Docker file, we need to build the image for it as well. So if we go to models.py file, on this static, we have the image name as static image artifact. So let's put that. You can put whatever you want. So Docker build -t tag the name of the image and then the location of the Docker file, which is sandbox static. I'm going to hit enter. Now that we have the image ready as well, we are ready to run our code inside of the container. But before that, if we go to our application, I'm going to run my application again. If we go to the application, as you can see, we have code where we already generated the code and we can see the preview of all the chat history. But preview, how does this work? So by this time, you might have guessed, we are running our code inside of the Docker machine and it opens a port, export, let's say 8080, 8000, whatever on our machine. So we need to open that port, or we need to access that page on localhost 8080 and display it on this page. So for that, we are going to need an iframe. So let's get building that. So I'll go to app.py, and here, just before our application entry point, I'm going to create a function called render in iframe. This is going to get an URL, so it's going to be localhost 8080, localhost 3000, whatever. And I'm going to sleep for 3 seconds because sometimes the Docker container needs some time to run so that whenever we try to access the port, we can get the web page immediately. So you might have to tweak this value to 3 or 5 depending on how huge your application is. This is just a debug statement. And then on the tab 2, as you have noticed on our application, this is column 2, this is tab 1, and this is tab 2. So on tab 2, this components is from Streamlit. We want to render an HTML, which is going to be unified iframe HTML, which we do not have yet, but we will create. And on this unified iframe HTML, we are just replacing the URL. And the height of the iframe is going to be 800, and we are going to set scrolling as true. Let's create the unified HTML, iframe HTML. So I'm going to stop my server, layout.py, go to layout, and I'm going to paste the iframe, so which is going to be stored in a variable called unified iframe HTML. These are just the basic styling of the iframe that we will be showing. So you can go through this code, or you can ask LLM what this is doing. I'll not go into details of this because this is not the goal of this video. So once we have the layout, I'm going to import from layout, import unified iframe HTML. And as you can see, I need to go to references. I'll go to the reference format, src equals to URL. So let's find the src on our layout. As you can see, this is the only variable that we need to pass. Why? Because it is opening an iframe and it needs to open a certain URL on that iframe, and that's all we are passing. Well, with that in place, we are going to be needing yet another function that is going to handle the renders. So I am going to paste it here. So this is going to be called handle renders. This is again going to take artifact metadata. This is kind of like the core to our whole application. Currently our web address is none, so we will try to match artifact metadata.name. If it's any one of these, we are going to execute docker, where the host path is going to be the directory name of the file path. So what do we mean by this? Let's say our application, our generated code is saved in the location tmp/run.py, or let's say in this example index.html. So what we are doing is the host path that we want to mount inside of the Docker is going to be just temporary directory. We are going to mount the directory, not the file, because the directory already contains the file. So .dir name will get the name, which is going to be /tmp, and then it's going to volume mount the container path. So our index.html file is going to be inside of home runner app index.html/index.html while it's running, because of this. And if the case is Vue, we are going to mount the file path directly. We are not going to have a directory being mounted. So let's say our app.vue generated is going to be /app.vue. We are going to mount /tmp app.vue inside of /home/runner/app, and let's say maybe view app src and app.vue. So we are going to be replacing the app.vue inside of the container with the app.vue on our local machine. That's kind of it. And if the artifact metadata has a host port, then the web address is going to be localhost, and the host port, we don't need to figure out what the host port is because we have already mentioned it on our artifact metadata. And then the render in iframe function that we created earlier, we are going to pass the web address URL, and it's just going to pass it to the iframe, and we are going to load it. So before we see this in action, let's come down and paste these two variables. It's calling the stop container function container name. So let's say if we have already an existing application running, which is static artifact based, so we'll have the container name always like LLM artifact minus static, and we want to create a new one. That container is not killed, let's say, then we will kill that container. And on the handle renders, we are going to pass the artifact metadata, which now contains the file path of our host machine where we have saved the generated code. So artifact metadata.filepath will contain the file we wrote that was generated from the large language model. And now it's time to run our application. So Streamlit run app.py. Let's go to our browser. Let's refresh this page. I am going to be using static. So for this, I'm just going to write create a travel website. That's kind of it. So it's generating the HTML, rightfully so. Its HTML generation is completed. Now it will be running the container. And as you can see, we have this application running on localhost 8080. We are creating an iframe and we are opening that localhost 8080 onto this iframe. That's how we are getting all of this. And here are a couple of like quality of life things. If your website has not loaded yet or the container has not loaded it, you can refresh the page from here. You can go full screen because why not? And if you want to see in its full glory, you can press the Jap icon and you can open the localhost 8080 and interact with the application. This looks kind of dull. So you can also have a follow-up prompt for it, like make the background blue. And this will again like go down to the chat. It will generate all the CSS that's required. And once it is done, it's again going to run it. And if I refresh this, the background is blue. I expected this to be blue, but I should have said header. But anyway, it followed the instruction and it looks amazing. So you can iterate with it again and again. And if you want to use a local model, let's refresh the reset button and the download file are not working. So let's fix that first and we'll come back. So for that, we are going to come here and we are going to paste if reset. And this is going to be on the same level as call1 because we want it to be inside of this column. This is call1. And if we have reset button pressed, we are going to stop the container with the container name, and we are going to clear all the session states, and we are going to delete any file that is existing on our temporary directory. And then we are going to rerun the application. And if you want to download any files, we need to create a function to download an archive from inside of the container, and we will generate a button to show the file download. For now, we are just naming it as project.tar by default, and it needs the mime type and just the icon. Data is going to be archive. You can play around with this to change on different format maybe, but by default, it's better to get a tar file from inside of the Docker container. So let's implement the download project archive as well. So let's go up. I'm going to put it on top of the application entry point. So this is pretty straightforward. Again, we are getting the Docker client and we are getting the container ID from this session because we need to get the files from the current session. And if there is no container ID on the session, we just assume that user pressed the button and there is no file to be downloaded. We'll get the container based on the container ID, and then we will get the archive. So the Docker Python SDK has this handy get archive file. And since our Docker container always have this as our working directory, we can just say whatever is inside of this directory, create an archive and give that back to me as bytes.io. I'll write a tar file and just return it back, right? That's kind of it. And if there is error, we are showing the error. That's kind of it. Let's go back to our application. Let's select static. Let's use the local model and I'll say create a travel website. So this will be using Llama 3.2 on my machine, but you can choose whatever model you want. So it's generating all of the code. If you have a powerful machine, then you can run bigger models. They will be providing you with better results. Or if you have any fine-tuned models that is very good at generating HTML code, then you can use that as well. So let's go to preview. So this is definitely a bit underwhelming compared to when we were using the remote model. But anyway, we have a website, we have all of the controls and whatnot. So next, if you want to reset the application, we can press this. It will clear everything up. As you can see, like no state, no nothing. And again, I can use the prompt. So I will disable the local models and I'll use the live model again. Again, I'll say like create a travel website for a digital nomad, maybe this time around. And this is generating the code. We can just sit here and relax until it shows us the banner that our application is running. Yep, we have it running. Preview, yeah, co-working. So it added some details related to co-working spaces, visa information, because you need all of that if you are a digital nomad. So this was generated by LLM, and now let's say I'm happy with the result and I want to download the code and work on my own machine, right? So for that, I can press download files. And another button is there. I think this is kind of like a gotcha in Streamlit. There was no other way to like directly download the file. So I need to download the project file again, where I'll be saving it inside of my demo video. So the name is project.tar. I'll save it. And if I go inside of this, if I unzip it, here is my index.html. And if I open it with Visual Studio Code, I can see all of the code that was generated by the large language model. So I can just take the code, edit it, and make it my own. It's really handy. And you are able to do it all on your own machine, on your own container. You control everything except large language model, maybe if you are using a hosted one. So that was really fun. So we got the static working, but still we have two more artifact metadata type that we need to make it work. So one is Streamlit, another one is Vue. So I'm going to speed run through these because you have already seen how I made the static one. So let's go. I'm going to stop my server. Then I'm going to create another directory called Streamlit inside of the sandbox. And there I'm going to create a Docker file. So if I look at sandbox, static, we already have a Docker file. Inside of the Streamlit, I have another Docker file. And this Docker file is going to be a bit chunky, but like this is not that overwhelming. I'm pulling the image from public ECR, so you can pull it from Docker Hub or public ECR. My choice is public ECR for this one. And I have this block of run command where I am creating a new runner user. And then I'm just basically installing all of the dependencies here. So this is where you have the control of the sandbox running your code. So you can have all the dependencies you want mentioned here. You can install them depending on your use case, depending on your corporation's use case, and on the prompts, you can basically list them like, hey, here are the libraries that you can use to generate whatever solution you are generating. And if you need something more, you just add it here and you update on the prompt and you're good to go. This was the base image where we are just installing all of the dependencies, and on the main image we are again creating the non-root user. Our working directory is always going to be home runner app, and we are going to copy all of the Python libraries from the previous build. We are going to create a default run.py file which is importing from Streamlit, and it's just like, hello world, welcome to Streamlit application. And we are going to create a Streamlit configuration where the server is going to be headless, and we are going to enable cores, and we are going to disable some security features, and that's kind of it. And we are going to be running this container as the user runner. I'll be appending the path as home user local bin because I need the Streamlit binary. And this is just the metadata where I'm exposing the port 8500 and then using this command. So this is where my Streamlit is located. I mean, having this, I can remove this as well, but just as a safety net, might not work for some of the viewers maybe. So I'll put this in place, then run.py. We are going to open the port 8500 and the server address as 0.0.0, which is our whole network stack inside of the container. So that is our Docker image. So once I have this, I am just going to build the Docker image. And again, I have to come to models. I have to check, what did I name the image? It's Streamlit image artifact latest. So that's what I have. And the Docker file is inside of the Sandbox Streamlit. I'm going to build this image and I'm going to run my application again just to check if the Streamlit application is running. Refresh. So right now my artifact is Streamlit. Let's say I want to password generator application, and I will hit enter. It's generating a Streamlit application, as you can see. And now on our preview page, we will be able to see an Streamlit application. Look at that. And you can like play around with it. You know, you want the password length to be this, generate password. Here is our generated password. That's really nice. Let's add something. Let's say when I press generate password, throw confetti. So this is going to, like, here is my prompt, second prompt. This is going to update it. It's going to run it again. And let's say I include this again. Look at this, balloons, but I wanted confetti, but yeah, it understood and it tried to do something about it. So this is pretty nice. Again, I can download the files, project R1 again, go to my directory, open it up, app run.py, open on Visual Studio Code, and I have the whole code for myself, which I can modify and use it for my liking. And now the last one is the Vue application. So this is probably going to be the most fun one. So for this, you need to have Node.js on your machine just to build this up. So for this, I'm going to go inside Sandbox and I am going to run npm create Vue latest Vue, and the name of the app is going to be Vue app. I'm going to press enter and I'm just going to select JSX with space, enter. That's pretty much it. If I look at the directory, I have the Vue application and I have all of this project scaffolded for me. And now to install some dependencies, I'm going to go inside of the Vue application and I'm going to install some dev dependencies and some runtime dependencies. So I'm going to be using Tailwind CSS for styling the application, Axios if I need to make any API calls, and then like all the other stuff. Let's press enter. This is going to install everything. While this is being installed, let's look at what is inside of our Vue application. So inside of public, we have a fab icon. Inside of SRC, we have a bunch of assets, base.css, logo, and we have a lot of components as well, which we do not need. As I showed you earlier, app.vue is the only file that we care about. We are going to generate all of our code into a single app.vue file and mount it here. So I will be deleting base.css, logo.svg, and the components directory because we do not need it, like I mentioned. So let me run this command. These are gone. We have our main.css. I'm going to delete everything. And here I'm just going to put import tailwind.css. And I'm going to go to whiteconfig.js. I'm going to select all, delete all, and then I'm just going to paste this in. So this is the default plugins that I have that will make Tailwind CSS compatible with Vue.js. And now it's time to create the Docker file for our Vue application. So for that, I'm just going to do touch Docker file. We'll have our Docker file inside here. I'm going to open it, and this is going to be pretty straightforward. So again, the work directory needs to be this. We are going to copy package.json, and we are going to install everything. We are going to copy everything inside of our application onto our work directory. And then we are going to expose the port, and we are going to run it in dev mode on port 3000. And if you go to models.py file, we can see for Vue application, we have the name as Vue Artifact, ports are 3000. Let's create our Docker image. This is no longer inside of Sandbox Vue app because I'm already inside here. So I can just say dot, because this is where the Docker file is located. Let me press enter. And as you can see, the name is again like Vue Artifact, image artifact. So this is created. Now it's time to run our application again and check if this is, I need to actually go back for this. Now it's time to run our application and check if the Vue container is running or not. So let me go back to my application, refresh this. Now I'm going to choose a Vue application. For this, I'm going to say create a tic-tac-toe game. Generate, let's wait for it. It's running, and bam, we have our Vue application. It's pretty interactive. It's very nice. I can like play it full screen as well. This looks kind of, bland, and I can say make the background pop. So let's go to the code. So yeah, so the background is pretty nice with the gradients and everything. So again, let's see here. This is pretty awesome. And again, for the Vue application, download files, download the project file, save it. And once you open it, it's going to extract everything, and you have all of this here. And let's say I can new ghosty tab here. And if I do like, let's say new vim dot, as you can see, everything is here. All of my code is here, and I can basically modify it, do whatever I want with this. I own it. And I think by this point, you get the gist. If you want more artifacts to be generated, let's say for React or any other application, maybe you want to build charts with Chart.js or anything else, you can create an image for it, and you can specify on this artifact metadata selector. You can create a custom prompt for it, and you can add an option for it here. And that's about it. You change the code in maybe like 3 places, and you have your own secure sandbox running on your machine with all the dependencies that you desire using either local LLM or a hosted LLM end to end. That's really amazing. If you open the Docker desktop, you can also see all of the container that we are running on our system. So we have a static, Streamlit, Vue. So if I want to go and see like the logs, you can do it from here. You can inspect. And the best part is you can look at the files. So as we saw, our files are inside of home, runner, and application. And here is the index.html file, which is again volume mounted from our local directory. And if I go to Streamlit, I can see there were some errors apparently. Anyway, it didn't stop our application. So if we go to files and go to home, runner, and then onto the application and run.py file, as we can see, this is volume mounted, and the config.toml file that we saw earlier. We can do edit file and see like what is inside of here, and we can also see like run.py file, what is inside of here as well. So this is pretty handy. You get the overall observability of your system on your own hands, so you know exactly what's going behind the scenes because you wrote it and it's in your system. Thank you for watching this video. If you like this video, give me a thumbs up. If you want to see similar contents in the future, subscribe to my channel. And if you want to connect with me, I have all my socials in the description below. Thank you for watching, and I'll see you in the next one.